So we talked about x squared already. We've talked about x. We've talked about the absolute value of x. Instead of analyzing x cubed, x to the fourth, x to the fifth separately, we're going to put them all in one pile. It's called a polynomial. Okay? Now, we're not into the poly part of the polynomial because we're just looking at these different degrees. X squared, x cubed, x to the fourth, x to the fifth, x to the sixth, x to the seventh. Okay, we'll just stop there. X cubed, x to the fourth, fifth, sixth, seventh. Now, you can kind of tell some of these look similar to some other ones. Like, there looks to be like two groups of these different graphs. Let me get rid of x. You got some that go up and want to stay up, and then some that start from the bottom and go up. Can you figure out the different groups? Go ahead, try to figure this out. Discuss it with your neighbors. First of all, everybody should have these in, and then why don't you just delete some. It's like maybe I think 2, 3, and 4 look similar, 5, 6, and 7 look similar, and then I'm like, wait, no, 2, 3, 4, they're not similar. And then maybe I add in 1. You guys didn't get the paper? I'm sorry. My apologies. Does anybody else not get the notes? Mr. DeGeese, did you get them? No. We're not really taking notes just yet. We're more just investigating, so please make sure we have graphed and we are investigating.
I actually did all that data.
No. Go ahead and graph it again. That'd be great. So, which ones go together? Have you figured it out?
Yeah.
You have. Have you figured it out? Almost? Please continue to investigate. What's going on with this?
Yeah.
Just put the 2.
Oh.
Make sure we're Zoom standard as well, Zoom 6. You got a good group right there, Mr. Steck. I like that. Did you figure it out?
Like why it goes.
Which ones look the same? Which ones end up being similar to each other? Did you figure it out?
No.
No? But you're trying, right?
Yeah.
That's all right. Good. Mr. Steck, you have a beautiful graph. Which ones did you eliminate to get your graph?
I eliminated the odd numbers.
3, 5, and 7. And all of a sudden, oops, there's 7. We have this nice looking graph where everything ends up. Okay? Because of these even powers, anything to an even power will always be a positive. All of these even powers always want to end up. Okay? So, we're not going to investigate x cubed. We're not going to investigate x to the fourth, x to the fifth, x to the sixth. Instead, we're going to say, like, any x to a power where we have an even power ends up looking like this. This U shape. Everybody create the U shape. Please create the U shape. Don't be afraid. Now, U shape, even power. You don't have to do that. Even degree. U shape. Okay? Even degree, U shape. Now, we look at the odd degree. Let me just change this to 3, 5, and 7. They all have this kind of squiggle shape, where it's starting like y equals x at the bottom corner, coming up and going back up. So they all have kind of this shape. Okay? Now, a polynomial function is not just an x to a power. It's like an x to the n plus more x to the n. I use this, I don't want this to confuse you, but it's not just x cubed. It could be x cubed plus 2x squared minus 5x minus 5. This is a polynomial function. It's got multiple terms, okay? But things that are always consistent about polynomial functions is that they're always whole numbers, and it's always going to be positive whole numbers in our exponents. Okay? Now, Mr. Steck, you were working with an even one. That was your beautiful picture. Let's look at x to the 4th. Let's just delete everything, and everybody please graph x to the 4th. Now, I'd like you to add or subtract any number of things, any number of x cubes, x squared, x's, add and subtract, change it. And I want you to tell me, is the ultimate U shape going to change? And if it does, maybe figure out what still remains the same. So do anything. Now, the key is you have to subtract something with a power that is less than the first power. So add or subtract something with an x cubed next to it. Don't subtract like an x to the 9th, because that'd be changing what you're looking at. That'd be changing it to a x to the 9th, an odd degree. What shape does an odd degree have? That. And that's what you saw. Okay, so sure, maybe I'm going to add 5x squared. Just do whatever you want. Tell me what happens. Even though I have a bunch of stuff going on to the right, do I still have a U shape? Okay. Did anybody else do anything differently where they're like, not necessarily a U shape anymore, Mr. Mester? What do you got, Mr. Rasmussen? What'd you put in?
I just subtracted 5x to the 5th.
So here's what's important. If you subtract 5x to the 5th, what you're actually doing is graphing 5x to the 5th minus x to the 4th, or plus x to the 4th. This is now, and we'll talk about this, this is what's going to win. This is now an odd power. And so you probably see something like x cubed where it comes up, right. So we're not surprised to see that, but this is why we have to make sure the degrees are less. But let's do maybe 5x cubed. Whoa, hold on a second. Is it a U? Not perfectly. It's now got a little hump in it, but what is consistent? It's up. It ends up like this, right? Maybe I try x to the 4th. Okay. Sorry, x squared, not x to the 4th, because that'd be the same. Whoa! It's not a U anymore. It's got some humps in it. It's a W, but what is consistent between this graph and this graph of just x to the 4th? Still ends up, okay? This is very important. So long as you know what your highest degree term is, no matter what you do, which is why we're lumping all these things together, which is why we're not doing so much crazy analysis of each one, because there will be some consistencies. So 5x to the 4th, let's see, minus 2x plus 3. The plus 3 is just going to shift it up. Like, I can't believe I keep doing x to the 4th. X cubed, okay? It could look different, but we know it's going to end up, okay? This could go with x cubed. I can add like a 6x squared. Now, it's not what we think of x cubed being. X cubed looked like this. It's a little bit different. It's going up, then down, then up. But we know this will have to happen, and this is what's going to have to happen. Okay? So this is what we call end behavior. Polynomials have consistencies with their end behavior. U's will stay U's. Things that end up diagonally would end up diagonally no matter what's going on. So this is why we're lumping all of these x to the fourth, fifth, sixths together, because of the consistencies. Okay, so this is a polynomial. It's just like a bunch of things being added together with degrees that are positive and whole number exponents. The degree is the x to the highest number. This will dictate what's going on. So if I have y equals x to the fourth minus 3x cubed, I don't actually care about the 3x cubed. I say this is going to look like an x to the fourth graph in the end. This will end up with a U type end behavior. Does this make sense? I just showed you. If I have x to the fourth x to the fourth, it looks like a U. No matter how I adjust it, so long as I'm not adding or subtracting anything that is like higher than x to the fourth or equal to x to the fourth, say I subtract a 3x cubed, it will still have an end behavior of a U, like we see right here. Okay? So, this is going to dominate this degree. Standard form lists things from highest degree to lowest degree. Now, back here, x to the fourth. Oh, let's go back to x squared. What happens if I put a negative number in front of x squared, like -2? Please talk to your neighbors. What happens if I put a -2 in front of x squared? Tell them. What happens? What happens? It's going to get wider. It's going to get wider is a good guess. Graph it for me. Please graph y equals -2x squared. Let's go to zoom standard for me. Can you go to zoom? And then 6 is standard. And that'll make it look nice like everybody else's. Ms. Crabtree, you said it's wider? Are you going to change your answer? You're going to graph it and then you're going to tell me? The same? -2x squared. Why don't you sit up here, Mr. Charles, because you're having a tough time seeing. You're going to sit where Mr. Charles is sitting, Mr. Clark. That's what I was saying, because you're having a tough time seeing. What happens? It's going to shrink. It's going to get narrower. But what else is it going to do? Flip. It's going down. Yes, it's reflecting. I like that over the x-axis. So, now, go back to our x to the fourth minus 3x cubed. It doesn't look just like a nice U, sure, but we know the end behavior, x to the fourth minus 3x cubed. We know the end behavior ends up being a U because of this even degree. Well, if I put a negative, say 2 in front of this x to the fourth, it flips. But the end behavior is still that U shape. If I have an x to the fifth, say minus a 5x to the fourth, x to the fifth is going to dominate. I know this is an odd power. I know it's going to be this diagonal end behavior. Here's my diagonal end behavior. If I put a negative in front of it, it'll flip. It's going up and then it ends up down. You might not be able to see that. Okay? So the key, and we learn and talk about this a lot in calculus about like how the highest growing or the fastest growing term will dominate when we're talking about polynomials. We're always going to focus ourselves on the highest degree term. And if our highest degree term is even, and we have a positive coefficient of this highest degree term, we're going to end up going up like this with our end behavior. We'll talk about this x approaches negative infinity and x approaches positive infinity. If we have an odd degree, we end up like this. So, even degree, odd degree. If we flip it, even degree will flip, odd degree will flip. Okay? Now, what we're talking about with these infinities is like, which direction are we going? As, go back to my favorite. As x is going all the way over here to the left, my function values are going up and up and up. As x is going all the way to the right, my function values are going up and up and up. We will fill in infinities always for these answers, and it's based on our shape. If I'm going up, I'm approaching a positive infinity for my y's. If I'm going down, I'm approaching a negative infinity for my y's. If I have an x cubed, or an x to the fifth, or an x to the seventh, an odd degree polynomial, we will either be going in the same direction or opposite directions, depending on my shape. Now, all of these we'd be able to check by graphing, but we will find that it's just easy enough to just examine and look at the polynomial to get the answers, okay? Okay, so here we go. Very short notes. Y equals 5. We can graph y equals 5. Go ahead and graph y equals 5. Graph y equals 5 in your calculator. We'd say this degree is 0. And the end behavior is horizontal. Okay? That's not really a polynomial. So just like, don't worry about that. Just y equals a number is just a horizontal line. But now we're getting into polynomials. 2x plus 3. We would say, okay, 2x, that's the highest degree term. It's got a degree of 1. Its leading coefficient, 2, is positive. 1, odd or even, Mr. Black? Odd. So, if it's an odd degree, what will my end behavior, what will my graph look like? Please, everybody, use your arms. Up and down. Good, that's it. So we're thinking up to the right, down to the left. As x approaches negative infinity, I'm going to be going down. As x approaches positive infinity, I'm going up. If you get this, great. If you don't, you'll get it soon enough, just as long as you understand that. Okay, now we have a quadratic x squared. Degree is 2. Ms. Brown, is 2 an odd or an even number? Even. The leading coefficient doesn't exist. It's just 1. That's positive. Okay, everybody. Even degree polynomial, what will its ends look like? Make a graph with your arms. Both arms are necessary. Go. Yeah, you can use your head. Boom! Every even degree polynomial will end up with a U, a touchdown. Either a touchdown or a negative touchdown. We're going to go up. An x cubed I don't care that I have this, this, and this. I can ignore it. It's not going to change the end behavior, just like I showed you. This number, Mr. Garcia, odd or even? Odd. The number in front of it is a positive. There's no number in front of it. With your arms, what will an odd function, polynomial function, look like with a positive leading coefficient? Leading coefficient. So here's the thing. You got two options. You got this or you got that. Y equals x cubed looks like this. Y equals negative x cubed will look like that. So if I tell you to use your arms, you have a positive leading coefficient and it's odd. You're this. You're x cubed. Okay? So everybody, odd, positive, go. Everybody should be doing it behind my back. I'm going to turn around. 1, 2, 3. All right, good. All right. X to the fourth. Ms. Abernathy, what is the degree of our polynomial? 4. Is that odd or even? It's an even number. What's in front of it? A positive number. Everybody, please tell me or show me what the end behavior of this function will look like. Go. Go. Don't be afraid. Nobody judges here. Good. U. Some sort of U. This. Some sort of U. This. Some sort of that. Okay? These answers are not important. If you got this, you should be able to get this. Okay? As x approaches negative infinity, we're going down. As x approaches positive infinity, we're going to go up. We will work on that if we need to next class. Here, this is both going up to the right and to the left. It's like to the left, I'm going up. To the right, I'm going up. That's really what it says. Here, to the left, I'm going down. To the right, I'm going up. To the left, I'm going up. To the right, I'm going up. That's what that means. All right, now, change it up. X to the fifth, odd number, but the leading coefficient is negative. Think about it. Remember, and we can always go back to the difference between what x cubed and x squared looks like. Even power, the most basic even power is x squared. It looks like a u. The most basic odd power is x cubed. It looks like that. Okay, so x cubed normally. X cubed with a negative in front of it. Go. Good. Yeah, so we flip it. So we end up coming from up top, and then we end up going down. If I look to the left, I'm going up. If I look to the right, I'm going down. X to the sixth, that will dominate. That's an even number. But I got a negative in front of it. X squared with a positive, this is what it looks like. That means x to the fourth. That means x to the sixth. That means x to the eighth. X to the 10th will always end up like this. But if I have a negative in front of x to the sixth, what will it look like now? Go. Use your arms. X to the sixth with a negative in front of it, Mr. Black. X squared, x fourth, x sixth, negative x squared, negative x fourth, negative x to the sixth. If I look to the left, I'm going down. And if I look to the right, I'm going down. Okay? That's simple. Now, sometimes they try to trick you. Don't get tricked. You look at y equals x squared plus x cubed minus 1 minus 4x, and you might think x squared wins. But no, that is not the highest degree term. That is not what's going to dominate the function. So what we would make sure we do so that we don't make any errors is we rewrite it in what is called standard form, writing things from highest degree to lowest degree. We see that 3 is the highest degree. We see that it's a positive. Please write down, if we go to the left, am I going up or down? And if we go to the right, am I going up or down? I'm walking around to see if everybody is going to get this right. If I have x cubed and it's a positive number before x cubed, my degree is 3. That is the one thing that's going to dominate what this polynomial looks like. What is my graph going to look like all the way to the right and all the way to the left? What is the end behavior, which is always common with all of your odd functions? Sure. I'm coming around. Nope. You have the right idea. Nope, but the right idea. Use your arms. What does it look like? What does x cubed look like? What does x to the 5th look like? What does x to the 7th look like? This is x cubed. This is x to the 5th. This is x to the 7th. What do you think x cubed plus x squared minus 4x minus 1 looks like? If I go to the left, am I going up or down? Everybody, if I'm going to the left, if I'm going up or down? Down. If I go to the right, am I going up or down? Got it? I hope so.
Up or down.
No. You're better than that. Infinity symbols? Yes. Sideways 8s? Yes.
No, but my hand won't right from sideways.
Just do your best. Look at mine. Mine are ugly. Now, this equation, g of x, please write it in standard form. Then please identify the degree, the most important number, the x to the power, which will dictate the shape of this polynomial where we look at the ends. So we write it from biggest to smallest in terms of its exponent. X to the 4th will come first. What's next, Mr. Garcia? I got rid of this x to the 4th, so that's gone. What's next? Which one? It's 2x squared and 2x cubed. Which one goes next? To make it look really nice. I'm rewriting this so it makes it look really nice. Okay? I got rid of the x to the 4th because that was the biggest exponent. What's next?
Minus 2x cubed.
Yes. The next one would be minus 2x cubed. The next one would be plus 2x squared. The last one would be 4x. What is the most important number? 4, 3, 2, or 1, or this 4, or this 2, or this negative 2, or that negative 1? What's the most important number? The 4. What does x squared look like? I know, I'm exhausted too. What does x to the 4th look like? What does x to the 6th look like? What happens if I put a negative in front of this x to the 4th? Thank you. It's going to flip. If I go to the left, if I go to the right, where are my values going? Up or down? Go ahead, write them down. Oh man, are you a lefty? No, you're not a lefty. You're a righty? Those just look like a struggle. It's okay. Good. I like this. Miss Pierce. Miss Pierce, am I going up or down? Down. Now, what we're going to say is going down, and in terms of a y equals x-axis, these are values that are down. When we have negative values, that is down. If I'm going up, that's positive value. So you wrote down, I love it. Now just convert it to that, okay? Very good. Basic features. The graph is continuous. There's no jumps. There's nothing crazy. It's smooth. Sometimes it's got some humps, but mostly what we're going to concern ourselves is how it ends. Up and up, down and down, down and up and down. The graph is continuous. The graph has only smooth turns. The end behavior, which is what we're focused on, which is why we are bundling all of these polynomials together, of a function with an even highest degree are going in the same direction, either up and up if it's positive, or down and down if it's negative. Odd degree, opposite directions. This is like summing things up here. You're either going down then up, so this is x cubed, this is the tricky one, that's positive, or you're going up then down if you got a negative. Exponents must be positive whole numbers. Okay? Some other things that we can describe, how we can describe polynomials is when is it going up and when is it going down. So not necessarily just the ends. We can say, okay, as x, and I'm going to put this in here, as x approaches negative infinity, what are my function values doing? Please discuss this with your neighbor. I'm giving you the graph. I want you to answer this question. If x is approaching negative infinity, what's f of x doing? I'm calling on somebody randomly. Please discuss so that everybody's got the right answer. You got it? Don't just sit there, talk to somebody. Repeat the question. As x approaches negative infinity, what is f of x doing? Who thinks they got it? Who's got confidence? Mr. Saripata, what do you think? Yes. As x is approaching negative infinity, this is like as we are going to the left. This is negative infinity on the x-axis. Here's my graph over here to the left. Which direction is it going? It's going down. What will we say down is? Negative infinity. Cool? All right, good. Now, where are we increasing? This is not great. I don't want this to confuse you. We do this a lot in calculus, talk about when things are increasing or decreasing. We are going to look from left to right. It's like we live in America. In America, we read things from left to right. So why don't we read graphs from left to right? If I start over here to the left and I go to the right, my graph goes up, it then goes down, and then it goes up. Do we see that? It's important that we're reading this from left to right, because if I go from right to left, I'm thinking about things in the opposite direction. So, from left to right, I see my graph goes up, down, up. I would say I'm increasing from negative infinity until I stop increasing, which is 0. We are only looking at x values. I'm decreasing from 0 to 4, and then I'm increasing from 5 to infinity. This is another way in which we can describe polynomials. When is it going up and when it's going down? Now the next one is, when is f of x greater than 0? Like, what does that mean, to be bigger than 0? Positive. Okay, good. When they ask you about f of x, what are they referring to? What do we usually replace f of x with? Y. When are your y's positive? Here are positive y's. Here are positive y's. We would say it's from -2 to 3, and then from 5 to infinity. When are my y's negative is the next question. I'll do this in green. Y's negative. Here are negative y's. Here are negative y's. From negative infinity to -2, and from 3 to 5. You're going to have to do this sometimes when you are asked to describe what's going on with a polynomial. Evaluate the polynomial for x equals -2. Just please make sure you plug in things using parentheses. You don't have to do anything special. Just use parentheses and use your calculator. I don't know why we put that one in there. Okay, let's start our homework. I know we're back in math class. Great start. Ready? We're going to say if this is an odd or an even polynomial, and then we are going to write the end behavior. So first, with your neighbor, and then I'll call on you randomly. Is that an odd polynomial? Is it an x cubed, x to the 5th, x to the 7th? Or is it an x squared, x to the 4th, x to the 6th? Miss Reyes, what do you think? Is it going to be an even or an odd? You don't know odd? You do know odd. Okay, good. Next one. Ms. Villamore, this one right here. This is going to be an odd degree or an even degree? Even. Next one. Mr. Stein, odd or even? Even. Next one. Miss Wenson or Wesson? Wenson. This guy. This one's tough, but just look at the ends. Odd or even? Odd is correct. It ends up going down to the left and up to the right. It's an odd. Next one, Miss. Is it Mattingly?
No, yeah.
No?
Yeah, I'm sure.
Oh, it is. Okay. Is this an odd, like an x cubed, an x to the 5th, and x to the 7th, or an even, like an x squared, x to the 4th, x to the 6th?
An even?
Nope. It's an odd. Because x cubed goes down and up. X squared, ups, x to the 4th, up and up, x to the 6th. And if we're not sure about this now, we're going to use our calculator, and we can use the most basic odd and the most basic even. X squared, up and up. Okay, x cubed, different. So please make sure we're able to check.
I actually wrote odd on my paper and I said even out loud.
Fantastic. We all do that. I do that often. All right. Miss Chisholm, last one, odd or even? Fantastic. Now, tell me the end behavior, Mr. Irwin. As x approaches negative and infinity, I'm going to make it easy for you, and I'll make it harder for everybody else. That means I'm going to the left. If I'm looking to the left, am I going up or down? Down, and how can I write that? Negative infinity. And then as I'm looking to the right, if I'm going up or down? Up, which means beautiful. Miss Harvey, as x approaches negative infinity, f of x is approaching what for this second one? Yes! And how am I going to write that? Infinity is correct. And as x approaches infinity, f of x is doing what? It's going up as well. If I go to the right, I'm going up. We're on top of this, okay? It's not tough. I'll do the next two. As I'm going to the left, I'm going up. As I'm going to the right, I'm going up. Okay? I'll let you do the next couple. We should be able to write odd or even really quickly for 7, 8, and 9. Go. And we can put positives or negative leading coefficients for the next three. Flip-flop. This is good. This is good.
So
That's correct. That's correct.
just these ones, the letters.
Yes, this is an even. This looks just like x squared, so that's why it's an even. This is an odd because it looks more like x cubed. You got the correct leading coefficients, which is good. So please write odd, even, and then positive or negative leading coefficients. Miss Brown, 7 is even or odd? Even. 8 is even or odd? Yes, you are. 9 is even or odd? No, it's even. They both end up down. It ends up like a U. Okay? Now, hold on. Mr. Schumacher, is it a positive or a negative in front of my even power? It's a positive because I'm going up and up. Ms. Arbogast, number 8. Is this a positive or a negative leading coefficient? It's a negative. This is tricky. Why? X cubed looks like this. This is like a negative x cubed. That's a negative. All right, we'll practice before our quiz next class. Please do your best to finish this homework. It's not that large. Thank you. Good to see everybody.